Hello everyone, welcome to Baby STEM. Are y'all working with infant toddlers? Oh, you have infants or toddlers? Okay, good. Well, I'm extremely excited and proud to be here today. This is a great opportunity for all of us to really look and see what our earliest scientists and engineers are doing. And so I was invited to come. I'm Dave Scahill. My company is called The Discovery Source. And I named it that because I love science and math and engineering, technology, or otherwise STEM. I've been doing science workshops for teachers for over 30 years. So it's not new for me to talk about this. I've always been engaged and involved with it because I see the wonder and the discovery that happens with young children. They're given opportunities to be able to play. So, well, I'd like to start off showing a couple pictures of children at play, little toddlers especially, and remind you that you are the mind shapers. You are helping develop these little brains. Their brains are on fire. They're learning more at these ages from 0 to 3 than any other time. All the connections are happening all the time. So we want to give them as many opportunities for hands-on exploration and discovery as possible. So what is Baby STEM? You're all going to be walking away with a little curriculum guide at the end of this that's called Baby STEM. And it'll give you background information and experiences that you can do with your children. So it's about providing adults and caregivers with the foundation of early STEM, and especially the language of STEM. So really using language with children is what we're going to really talk about a lot today, because many of them are not able to communicate back to you yet. They're not talking or they're nonverbal, but they can definitely understand or begin to understand the words, the vocabulary, the concepts, and the more that they get to use actions along with the vocabulary is extremely good for them. So they're naturally curious. Obviously, everything they do is about touching and feeling and smelling and using their senses, and they're constantly exploring and discovering. We're going to talk about how it's everywhere in everything we do. We'll focus a little more on the math today, since we're looking at, and it's a early math conference. It's easy to introduce STEM concepts to very young children because they're so naturally curious. What is science, technology, engineering, and math? Well, you all know what those are, but the one thing I'd like to point out is that the technology that we're talking about is not electronic technology. The technology that we're talking about are tools that children use to help them to be able to do their experiments and to build their engineering ideas. So it's simple things like what we're going to use today, blocks and ramps and rubber ramps and blocks, and I think I said that twice. But those are the tools we're talking about for technology. So here's the scientific method. It's a little hard to read, but number 1, you're curious about something. Number 2, you pick it up. Number 3, you put it in your mouth. Number 4, you wonder, what should I do with this? 5, you start screaming or yelling or, what's happening? And then 6, you share with a friend and let them do it so they can explore. All right, so technology, again, like I talked about earlier, tools. So you can build a simple tool like this, where you may have a cup and perhaps a piece of cardboard or a piece of wood. You connect these two together, right? And we need a ball. So let's do a little ball. Use a little wiffle ball. I'm going to do it on top of the table so you can see if you're watching on video. We're just going to set the little ramp on there, put the ball here. And when we push on this, what do you think will happen with the ball? Let me try it again. So in this way, we actually mounted in the picture, you'll see it's actually taped or glued, so it doesn't really move that much. So I'm gonna hold it, and then we push, ball goes up. We make a simple tool, simple machine. And for kids like me, that was an amazing thing to be able to do, is stomp on something and try to catch it. It helped get a lot of aggression out, and it was fun. And you can test out different balls. They do different things, change the variables, and things change. So that's how we do different explorations. Okay? Engineering. So what does engineering look like in an infant toddler center? They're grabbing things and they're stacking them and they're putting them in different orders. Then they knock them over. They do it again. The engineering process, you design something, build it, it falls down or it doesn't work the way you think it is, and you redesign it until you do get it the way you want it. Or some early math, you can see there's colors, shapes, sizes, all the things we've been learning this morning. Counting, cardinality. I like using mirrors with children and give them that three-dimensional view so that they can see things from a different angle. Patterning is extremely important with them. And so what we're going to do now is we're going to have hands-on opportunities to play so we can explore and discover on our own. I like to talk with caregivers about watching what children are doing, listening to what they're talking about, and then engaging with them at that moment when they're already involved and excited about doing the kind of learning that you make available for them. So using questions and prompts. So here's one of the things we're going to do when we get into the hands-on opportunities and start working with the materials, is I want you to talk to children all the time. This is about the language of STEM. So when you're setting up an experiment or you're designing something, I want you to be the narrator and talk about what you're doing, okay? So I'm going to pick up this piece of wood, and I'm going to take this ball, and I'm going to roll the ball down. Oh, look what happens and just keep talking and talking. And then what is this called? This is an angle, right? When we have space between the floor and the ramp. And what happens if we lift this and we roll the ball down? What do you think will happen? And the older 2-year-olds or 3-year-olds, they might have a guess or a hypothesis. The younger ones, they just want to find out what happens. So you talk to them, talk to them, talk to them. Explain those concepts with speed, distance, momentum, gravity, are all things you can talk to them about. They may not understand them yet, but the point is that you keep talking about it, you show them, you let them do it, you parallel talk with them, and as they're doing things, you explain what they're doing. That's going to help them set it up for when they are communicating more and they're moving into preschool and they're getting more and more experiences with preschool where they can communicate back and they're talking back and forth and they're explaining their thinking, and that we have real little scientists and engineers and mathematicians. Okay, so far so good? All right. So the first thing we're going to do is you'll see I brought materials from one of the companies I work with, and they have fabulous STEM materials, and they're beautiful, and they're long-lasting and durable. But as you can see on the left-hand side, all you need is sturdy cardboard, anything that will make a ramp, so you don't have to buy materials to help build ramps. Children love moving things. And there's so much science and technology, engineering, and math that can go on with moving things that I wanted to bring materials for you to experience that yourself. So what we're going to do is take a volunteer from each table and come on up. I'm going to pass out some materials for you, so jump on up. Come on up. One person from each table. You don't have to go anywhere. All right, you can take that, and I need to give you a ball. So I want you to take a ramp, an arch, and a ball. Which one you want? I'll let you pick. Okay? And here's one for you. And let's see. Well, there you go. There's one for you.
Thank you.
All right, here you go. We need a bigger ramp for you. All right, does each table have one now? Perfect. All right, you need a ball? No. All right, go ahead and explore. And as you're exploring, we need someone at the table to be the teacher who's talking to the children as you play. Or you can all take turns and do it yourself. Go around the table and take this one little simple item. And things that you could talk about are, what are these made of? What are the properties of these materials? You can pass them around to the children, let them touch them, feel them, or you can just start exploring and see what you can learn with these few materials. Right, so ask yourselves questions. I heard over here, I wonder what would happen if you push on the side. I see over here, can you explain what you're trying to do? Talk to each other. What concepts you're learning there? So balance is one of the concepts you're working on here, and you're testing your theories? Huh? And what happens?
No, it's not because we need to hold it.
Do you think you, so what is your objective?
To keep the balance, to don't drop the ball.
To keep the balance so the ball won't drop off the ramp. And so you're trying different things until you can make it happen, right? I trust you will make it happen. Ah, look at this, same idea, problem solved. So once you solve one problem, go ahead and take a look and say, okay, what else can we do with this? What did you learn? What kind of concepts did you learn? What was this? What was this about? Balance. Yeah, design. They made a beautiful design. I knew you could do it. All right. So once you have that finished, what else can you do with it? Have you been able to keep it in the middle? It seems like everybody almost had the same idea.
We kept it on both sides, but turned the other way. So now we're like, what happens if we turn this?
Ah, okay, great. What would happen next if I try something else? Perfect. Ooh, some dramatic play. A boat sailing under the bridge. Which bridge? The Coronado Bridge? The Bay Bridge? The any bridge? Fabulous. The best kind. All right, all right, all right. Balls down, balls down. Ramps down, arches down. So, from this few materials, almost everyone thought, wow, I could lay this ramp on top of this arch and balance a ball. Right? How many of you tried that? Yeah. Almost every table, right? And then if you had additional balls, you could have taken that same concept and just kept experimenting. Well, I wonder what would happen if I used this large wool ball. I wonder what would happen if I used this rubber ball. I wonder what would happen if I use a ping pong ball, or if I use two different balls. So a single concept like that could go on for a variety of different experiments, and that's what we want you to think. If children are interested in that, and you've got their attention, and they give them more opportunities to play and discover, because what are they learning? What was the biggest concept? Anyone? Experimenting. Balance. And we have some where you have the arch that's moving more when you lay it that way, but if you stand it on each side, it was more secure. And we see that you did it all in different ways. Some of you tested both ways, right? So that's what we want to do. I want to take a simple concept and then explore with as many different ways as we can. So what else could you do? Let me give you a little challenge. can you make the ball roll down a ramp and turn direction somehow? Just by using the 3 pieces that you have. So you want to have a ball roll down and then somehow change directions. I'll give you a little hint in that one. This time I'm also going to give you a second ball so you can experiment with different materials. Oh, here you go.
Direction on the floor.
All right, I'm going to give you a special one. Be careful, be careful. Here, just in case that one's a little too much for you. All right. I'm going to add a new dimension to your play here. We're going to give you a flexible ramp. All right. And remember, I want you to be talking to each other and using vocabulary, talking about the concepts they're learning, especially around math. Here you go.
Thank you.
We need 2 more for you. There you go. All right, now we've added some flexibility where the other ramps were very solid. Now we've got some flexibility in there. So all of a sudden, there's a new level of experimentation happening. And so now using words like some of the words that you can use when you're... What are some of the words you can think of?
Speed.
Speed. Slope. You're on a curve, right? Excellent. Now, do you need momentum to get the ball down and then back up and over? So, now I want you to take a cup. Everybody take a cup. See if you can roll the ball off the table into a trap. This is your trap. So now you're going to need to estimate how fast the ball will go, how far it will roll off, and then try to catch it in a cup. So you're going to need to estimate. Pretty close. Make a prediction, and then test out your prediction or your hypothesis. It made it, but then what happened? Did you have a new problem?
Yes, the momentum of it pushed the thing over.
So the momentum pushed over the cup.
The force
So
of
the force, right? We're using the vocabulary now. Exactly. Perfect. Couple of pieces of wood. Oh, shore it up. So you're going to give it some... there you go. There we go. All right. All right, you've got 30 seconds to try to...
Almost.
Was in long enough. I give it the...
One more time.
So we don't have it right here, but what do you think might hold that cup in place?
water inside the cup.
Water could do it, or some other kind of little weighted, maybe something soft that it could absorb.
Yeah, we tried the piece
Possibly.
We tried the piece of paper.
Packing peanuts.
Do you have bean bags in your classrooms? Bean bag could kind of absorb that shock. And you would have figured it out in time, but we're running out of time. And I want you to succeed. So try something a little smaller maybe. That's going to take up the whole cup. Oh, sorry.
No worries.
All right. Everybody ready for the next thing? Okay, go ahead and put the put the cups and the balls in the cup and kind of just put everything down in front of you for a second. Yeah, as long as you can wash them, right? Obviously, toddlers put things in their mouths, don't they? And so you constantly have to clean things and keep them sanitary and make sure they're safe and that the materials are large enough that children won't, have any issues possibly choking on them or anything. And I may have a few smaller balls in here like the ping pong ball. It's from all the workshops I do. I wouldn't recommend using these smaller ones, but anything over an inch that doesn't fit in a no choking tube, is good. Are they going to throw these? Probably. So that's why I bring rubber and plastic wiffle balls. I bring wood too, so you can experience it. The older children will start using these as scientific tools and engineering tools and not as weapons. And I've been doing this for 5.5 years now, and I'm amazed how children can maintain their control. And when they're taught that these are scientific and engineering tools, STEM tools, they treat them that way. And I've also experienced many teachers tell me that my worst behavior problem kids are now my most engaged because I'm giving them these kind of open-ended materials. And did you play nicely together? Right? There's a lot of social emotional development, a lot of cooperation, sharing, problem solving together while you're engaged in this kind of play. So the other big thing that children love to do and has even, do you see the science in these activities? How about the technology? Right? The engineering and the math. So the math is probably the one that has the most because you've got speed and distance and angles and weight and sizes and all those, math readiness skills and vocabulary we want children to start thinking about and hearing, and then eventually expressing and being able to show what they're learning. So our next activity that we're going to do is about building. So children love to build with blocks, right? And then they also love to knock them down. And rebuild them and knock them down, and sometimes a child knocks one down where the other child wasn't quite ready to have it knocked down yet. And, how do you deal with that kind of situation? You don't want to stop them from building, right? You want to try to get them to build together and, learn how to share space. And we heard some great suggestions today on giving children individual mats to be able to work from. So it's their space. And they don't have to share it because 2-year-olds have a difficult time sharing sometimes. But as adults, we share well. So what we're going to do next is I'm going to give you some blocks and some planks and some cups. And we want you to either work in pairs or you can work in as a group to design and engineer something and build and build. So you can build wide, you can build tall, you can build a single as tall as you can go. No standing on chairs or tables. It's not a competition. You can start on the floor if you like. So once again, we're going to come up and gather some materials from each table. So one representative from each table, come on up. And this time you're going to grab some blocks and miscellaneous parts in there. And then we got some more blocks in here. And then grab at least a couple of these each. There you go. And there's 2 for you. And maybe this is the easiest way to do it, is just fill one of these. Or fill a couple of them. There you go. Are you waiting?
Yeah.
There you go. And you need some blocks. Oh, right here?
Yeah.
Okay. There you go. And there's for you. You need some blocks. Oh, there you go. Planks, do you have those yet? Here, I'm gonna give you all of these. These are different, but since you get different, you get more.
You look really
Oh.
excited for different.
Sorry, I can't. I gotta give her a couple blanks too. Oh, and you know what else you can use? You can use
Oh, okay.
this too. Yeah, we do have some different blocks over here. You want some of these? Yeah, there you go. Help yourself. Okay, so you've got materials. You can also use any of these materials if you want to, if they help. You're welcome. Can you reach all the way over here? Or are you moving it into the middle? This is also a possibility. These do fit like that. I think they fit. Let me see. Oh, yeah, there we go. Okay, so the beginning of engineering is solving a problem,
Yep,
right?
solving a problem, and then how you can make it better.
Or creating an idea that you might want to build tall. So I've given you a few more blocks. Do you think you could build a second story? You're having a new baby coming, and we need another room. And it doesn't have to be up. It could be anything. Whoa! All right. Same time. I should be taking pictures as well. All right. So I want you to take a minute. I think everyone's almost just about done or on their second or third design. Ta-da. Okay. All right. Give yourselves a big hand. All right, so these were a little advanced for toddlers. Well, go ahead, leave it. Oh. There we go, that's more like it. Fantastic. All right, well, I like to do these for one, they're fun, right? You guys you work so hard, you need a little hands-on excitement and opportunity to play. But I really want you to think about all the learning that happened while you were building and constructing. Like, what kind of lessons or concepts did you learn while you were building this structure together? Symmetrical. Symmetry. Balance.
Different sizes.
Yes.
Sizes, shapes, weights of things. Did it matter when you were putting an item on whether it was the same weight as the other side, or sometimes you needed something heavier on one side, lighter on the other side?
We also have to listen to other people's ideas.
Listening to other people's ideas.
Just going into it.
So working cooperatively and saying, oh, even if you don't think they're correct, you let them share their idea and try it. Yes? Being flexible.
Trying again.
Being persistent, keep trying.
Ideation, just coming up with ideas, experimenting and coming up.
So designing new ideas, having new ideas and designing them, and then experimenting and testing your theories. Okay? Friendship. Oh, you got friendship during this time. Wow, that's a new thing I'll add to the, come and make friends at Dave's workshop. Love it. Well, we were talking earlier about peer-to-peer interaction, right? And how important that is. And yours built all the way up and then knocked down?
and then you created a whole new world. What is your design all about?
I was gonna give some cheeky thing about the interpersonal play of design and
No, that was sounding good.
the juxtaposition of design and art. No, we just tried to use all the pieces in a visually appealing.
Using all the pieces seemed to be kind of a theme eventually, right? It's just like, let's add more and more to it and see where we can go with this and what kind of design comes from it. These are the kind of opportunities that I believe that we need to give young children, to let them explore and discover and play together and problem solve together. And most of all, when they're not verbal yet, to talk to them about those words and those vocabulary words and concepts that we talked about here today. Anyone have any comments they'd like to make?
I thought what was important was starting with an idea and then growing from that a small idea, because that's what helped us to kind of get to the next level of thinking. We started small.
So would you mind saying that again real quick?
Oh my goodness.
Just we started small.
Yes. Okay, so what was important for us is that we started with a small idea, and then from there, from using that idea, we began to grow and go to the next level. That was helpful for us.
Awesome. Anyone else? Now that I have the microphone, no one wants to talk. All right, fine, I'll put it down. You could just speak out. Anyone else? Oh, good.
I think something for me, just from here, is just keeping it simple. Because the more simple you keep it, the further kids can go with it. If you put too much constraints on it, then you limit where they can go with it. So keeping it simple.
Great. Great advice. Anything else?
I think it's important to share the language with the parents. So what's the language that you're using with your children in your childcare or preschool or on a home visit, and how it connects to math? Because I would do that on a home visit. I'd say, you know, he's building blocks, we're playing. This is math right now. And they're like, what? This is math? And so sharing with parents the importance of how play develops those STEM skills.
Oh, awesome. Love that. Especially with the younger ones. You know, as they get older and we watch the videos of children that are counting, well, babies aren't necessarily counting yet, but you can count for them, right? To get that language going, and then let parents know that there's so much math and science that happens that are pre-readiness skills to what they think is learning. Oftentimes, what they grew up with. They need to know their alphabet, they need to know their numbers, they need to know this, they need to know that. When they really need to know how to share and play well together and learn the early concepts, the pre-readiness concepts. Yes? Anyone else? One more. Uh-oh, I'm walking by you. No, I'm just kidding. Oh, all right, we got one more. There we go.
I think for babies and toddlers, I mean, think about they're exploring, they're just learning to walk and manipulate things. So it's a very natural, with their body rhythm of boom, 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 you know, walking, hitting on a drum. So maybe it's not counting, but it's the rhythm, it's the pattern, it's the experimenting. That is math on a very physical level.
All right, perfect. Well, I need some help. We're going to pass out the baby STEM guides for everyone so that you have your own. And anyone else who wants to come volunteer to help pass them out, that's great. All right, so before you go, if you wouldn't mind gathering all the materials and bringing them up to the front for me, I have to move my room to another room upstairs. So any help I can get in collecting the materials would be appreciated. I'm passing out other information about me. If I can ever be of service or of help, please let me know. Thank you very much for coming to this workshop today. I really appreciate it. Thank you.